So good morning, everyone, once again. So we have our second speaker for the day, Ms. Hazel Ko. I'm glad to introduce her. So Ms. Hazel Ko has done her bachelor's from Tamkang University, Taiwan, and she has done her master's MSc Management from University of Bath. She has worked as a production operator in Domex Technology Corporation during the year 2021. Later, she has worked as a student consultant in IBM London during the year 2024. Currently, she's working in the role of sales and marketing specialist in Jtron Technology, Taiwan. I invite Hazel Ko to deliver her expert address.
Thank you, Lenny. And I will now share my screen with you. So today we're going to use a comprehensive way to deeply look into wafer and IC testing. And thank you, Lenny, for introducing me. And I just have a brief introduction about myself. I will study Russian during my undergraduate. And as my master, I went to UK University of Bath and studied MSc Management. Regarding my work experience, I was a student consultant working on the AI recruitment process in human resource department. And then I moved back to Taiwan, joined Jtron Technology as a sales and specialist. For today's agenda, it will be covered 5 topics. It will beginning with the introduction of the semiconductor industry, following by unboxing chip testing. And then I will mention about the supply chain today and tomorrow. And lastly, if we got time, I want to use to represent that how a semiconductor testing company really works. So first, part 1, the introduction. I joined the opening yesterday, and I already heard that some people maybe already know the Moore's law, but let's just have a little review on it. The Moore's law, it's a fundamental law, but also an industry trend over decades. And generally speaking, in every 2 years, the number of transistors will double. The computing speed will also double. But the price of the same size chips will become half. In other words, the productivity and the output value will go up, while the price of IC will be going down. This is the Moore's law. And you can see there are many different kind of inches of wafer from 4, 5 to 12. I would say the 15-inch wafer do exist, but in terms of the yield performance and manufacturing process and also the cost, 12-inch wafer is the most efficient size for manufacturing production for now. And talk about semiconductor, the most popular word that we're saying and hearing every day is probably AI, artificial intelligence. It's very easy to find IC production in our daily life, like navigating a system in your car, the phone that we're using for communication every day, to buy things online and listening to music, watching videos, everything. It's driven by the semiconductor industry. So we will say the expected trend for IC will be smaller, faster, more accurate, and cheaper. When we build up the whole industry supply chain, the most important thing is to keep the process efficient and smooth. But there will be 3 challenges when we meet in the mass production. 1 is equipment investment, 2 is yield management, and 3 is the process. Imagine a production line with the perfect yield, but with the high cost, the really expensive cost. Ultimately, it's unlikely to gain a foothold in the market because it's too expensive. Nobody will buy it. Conversely, pursuing low cost at the expense of the product quality will ultimately damage the brand reputation because the quality is too bad. Therefore, finding the optimal balance between yield, efficiency, and the cost is the topic that requires careful consideration in every stage of the process. So overall, working on how to keep the balance of these three things is very vital in this industry. Moving to supply chain. The process can be divided into 5 stages. It all starts with IC design. So first, IC design. In this phase, engineers will design the function and the structure for IC, deciding how the IC works, perform tasks like processing data or storing information. After the designing, it will get into the process parts. We can also call it fabrication stage. Here, the chip is physically created and the silicon wafers in highly advanced facility called fabs. This involves multiple steps like mask and etching to build up the circuit layer by layer. Once the product is created, the chips are sent to assembly. Assembly is the stage where they are cut from the wafer and packaged, prepared for integration into electronic devices. And next, it will be today's topic, testing. To ensure the chips meet the quality and the performance standards, defective chips will be identified and discarded value to ensure only functional products are delivered to market, which is our next step. And all IC is ready to be shipped out to the market, selling, and will get the cash back. In every stage of supply chain, the most critical thing isn't about how advanced the technology is or how much money we invested in. The real key is actually the people. We need to have massive input of skilled and well-trained engineers to support and drive the entire industry moving forward. And now we're moving to our part 2, unboxing the chip testing. I'm not sure that all of you, maybe students, I'm not sure that whether you all know the difference, but maybe let's just have a review on it, on the difference on wafer, die, and chip. So begin with wafer. This is a thin, circular slice of semiconductor material, typically silicon, upon which IC are fabricated. Imagine it is a large canvas where many tiny chips will be created. And die, this is a single individual IC that can be printed onto the wafer. It's like a tiny square or rectangular piece of the wafer that contains the complete and specific function in it. And lastly, chip. This is the die after it has been packaged. The package provides chip protection, electrical connection. It's the final product that can be used in electronic devices. So, in a more simple way to imagine, wafer is just like pizza, and die, it's like a pizza slice. And chip, it's a packaged slice of pizza for people ready to eat. After understanding the basic information of wafer, die, and chip, we can now dip into the tester process more. As you can see, multiple testing sections between each stage of manufacturing a chip, from IC design to assembling and after assembling. And there are some abbreviation that we heard a lot in semiconductor testing, like WAT, CP, and FT. Okay, so let's see these slides begin with IC design. The test section right here is design verification. The designers design their ICs. They need to verify how this works and if there is gonna have a failure or not. Is the basic verification at the start. And in the wafer manufacturing process, there will be a WAT testing section. WAT stands for wafer acceptance test. It is very important, and it is a basic test section to analyze if this wafer is good or not for another process. And after WAT, before assembly test, there will be CP, which stands for chip prep. In this testing process, we use probe cards, which is with the small needles on it, and we will point it on the wafer to check its function and judging if this is a good die or not. And in the final stage, after assembling test FT, FT, it stands for final test. This is similar with CP, also a function test, but after packaging. After packaging, the die becomes the chip. And some people might say it is still hard to recognize the difference between CP and FT. We only know now is CP is during the wafer level, and FT occurs in chip level. But I want to share with you some more details about these two testing. Chip probing. CP is like very early test, right after the chip are made, but before they are cut apart from the wafer. We use a special machine with tiny needle-like probes that touch each individual chip. The machine sends electrical signals to the chip to check its basic function. For example, it checks if the chip has a short circuit or if the chip is open. If it's open, meaning the connection is broken. The main goal of CP is to find a bad chip as early as possible. If a chip doesn't work, we mark it with a small dot of ink, so we all know we cannot use it later. This is super vital because it saves a lot of money, and we don't want to spend time and resources on packaging a chip that doesn't work and is already broken. And moving to final test. Once the good chips are cut from the wafer and put inside the protective plastic box, they are no longer bare chips. They are now packaged products. Final test is the last and most thorough test. It's like a final inspection of the entire car after it has been fully assembled. During FD, we put the packaged chip into a special machine that checks its full functionality. This test is much more comprehensive than CP. The main goal of FP is to ensure the final product is ready to be sold to a customer. Only after passing the final test is the chip considered good enough to be shipped out to a phone company, a laptop manufacturer, or a car maker. And then it's our part 3. And this part, I'm gonna mention about our supply chain today. value chain activities where one single region accounts for 65% or more of global share. This phrase refers to a situation where a specific stage of a global supply chain, such as semiconductor design, wafer manufacturing, or assembling and testing, there's have 2/3 of its production capacity of market share concentrated in just one country's or region. For example, in the semiconductor industry, Taiwan accounts for over 65% of global market share for wafer manufacturing. This makes Taiwan a crucial player in global electronic manufacturing chain, but also make the global economy highly dependent on Taiwan's stability. In short, the phase highlights the high concentration of global supply chains and the resulting combination of both efficiency and risk. In this table, we can see in 2023, statistic on IC design company, also known as fabless semiconductor companies, showed that NVIDIA currently rank first. Next, let's look at Taiwanese company, includes MediaTek, Novatech, and Realtek Technology. And for the following table, you can see the top 10 global manufacturer in 2024. It's really clear that TSMC accounts for 62% of global market, while the remaining Taiwanese company accounts for 1 to 5%. That's quite high. Like we mentioned, if one region or one specific country accounts for 65% of market share, the other countries will have a highly dependence on the just one resource. And we have now seen the situation that supply chain have today. And what's tomorrow? What kind of supply changes or new requirements that we may see in the near future? In my opinion, there will be 3 expected trends may occur soon. First, it's geopolitical reshaping and regionalization. The global semiconductor supply chain is becoming less centralized. Nowadays, Taiwan is still the most significant role for manufacturing, as we mentioned. However, this has become a concern for worldwide governments. Now, the United States and Europe and other countries are investing hundreds of millions of dollars to bring semiconductor manufacturing process back to their countries. They're doing this to reduce their reliance on one single source and ensure the domestic chip supplies for both economic and national security reasons. This picture is TSMC's giant factory in Arizona in USA. And for the second trend that might be occur in the near future is the rise of AI and new demands. AI is having a huge impact that I believe all of us agree, not just on the product, but also how all industry operates. In semiconductor supply, AI can be used for predictive maintenance to prevent equipment failures. Also, generative AI and machine learning are also being used to automate chip design. And this will allow our engineers, IC designer engineers to accelerate fasten their work. And finally, we'll expect that talent shortage and need of the skilled workforce will be occur in the near future. It is a crucial issue that facing the future in the global semiconductor industry. We all know that semiconductor are the background of modern technology. As we previously mentioned, that the success of this race ultimately depends on talent, the people. In the coming years, we are going to face the severe shortage of engineers and technicians due to population aging and low fertility rates. Take Taiwan for instance, as a global leader in semiconductor manufacturing. Taiwan is facing a challenge of low birth rate. However, major companies like TSMC are now partnering directly to top university to establish semiconductor academies. These programs not only offers genuine scholarship, but also give students early exposure to the most advanced technologies. Additionally, Taiwan's already offers extensive manufacturing courses in not only university, but also in high school education. And the US government is also an example that they are now addressing this with Investing Cheap and Science Act. This bill invests approximately millions, 106 billions on the industry, including 2 millions specifically for training high-skilled workers. US government also provides funding for training and university program. And also, the famous university that you might heard is Texas Institute for Electronic Research Center. And the next example, I would say it's Korea. They also have significant invest in K-Chip Act. In 2023, this act provides up to 25% of investment tax credit and a 50% R&D tax credit to boost their investment in semiconductor manufacturing. Also, there are some European countries want to invest the act in the chips investment. But as I mentioned, talent shortage is facing for the global. It's not just the three countries that I have an example for. And since we got time, I want to use our company J-Tron Technology as an example to show you what we exactly do and what service and products that we provide to our customers. First, I want to introduce our vision. Our vision is to be a world-class service and solution provider in a high-tech industries. And how to be a world-class service solution? Our footprint have to be spread in the global. J-Tron's footprint spreads all over the world instead of Taiwan and China. Our partner locations also extend to Singapore, Malaysia, Korea, America, Europe, and Japan. There's some basic information to share with you. J-Tron Technology was established in May 2004, based in Hsinchu City in Taiwan. Our business scope covers a few, such as equipment field service, repair, and solution providing. And this is what I will talk about later. The number of our employees keeps expanding. For now, it's almost 300. Lastly, as our purpose is to be a world-class service provider, internationally quality certification is a must. For our strategy, Jtron technology is actually start with the business from APE, which is automatic production equipment. From here, we're extended our business scope to field service. The field service contains like installation, deinstallation, calibration, etc. We use Jtron self-developed system called Jessica to manage the variety of cost, works, and missions. Through Jessica, we can efficiently schedule and dispatch our engineering team to customer site. Next, hardware and software related services are also extended due to our strong RD team. Through keeping researching and developing, our clients can also require customized products from hardware side, such as subsystems, jig, and accessory like prop cards, and to software side like drivers, applications, and system like computer integrated manufacturing and enterprise resource planning, some system like this. By combining these different field services, we can call Jtron as a test cell integration company. So what do we exactly do? There are 4 parts in our service and products. First, engineer service. We provide field service to OEMs, which is original equipment manufacturer. The field service or engineering service like install, deinstall tester equipment, or do the calibration to check the function works normally. For example, our on-site engineers go to OEMs like Advantest, supporting them install big tester to their customer site. And the OEMs who we're also working with include Keysight, Seco Epson, Angelent, Kinanes, Ibarra, etc. Second, EOS service. You might ask, what is EOS service? It actually stands for end of service. Technically, this service, it's Jtron, is authorized by OEMs to extend their product or service life to their end customers. To explain in a easier way, if OEMs want to focus on their new products, they will ask external company like Jtron to do the service for their old products, because there are still many customers using the old products, right? As a result, OEMs can save cost, and company like Jtron can increase our business scope. And this EOS services include like system parts repair, contract refurbishment, and remarketing. Okay, so next, repair service. It's very straightforward, that from big instrument to a small component, even the medical devices that we can repair in our repair center. And lastly, it's integrated solution. With the ability of our best RD team, we could offer service not just in hardware, but also in software. And that's the reason why we could deliver a complete integrated solution to clients. And here's some brief introduction for our repair and calibration center. This is our repair zone and service model like Advantest, Keysight, Epson handler, also the workstation part. And finally, here's our clients. Of course, there are more of the list. Some people may ask, why we can own the clients from OEMs to OSAT. As I mentioned that we as a test cell integration company, from automatic production equipment, field service covering hardware and software, we can not only provide a single service, but a whole solution to our end customers. And we believe this follows nowadays trend that integrated service provider can be the most advantageous one in the industry. And I think that is our presentation for today. Thank you for all for listening. If you have any questions, please let us know.
I invite questions from the delegates. So I think there's a couple of questions. Let me check. So there is a question from an audience from Mr. Veera Babu. So what are the steps to be taken to avoid the buzz on talent shortage? So what is remedial steps to be taken to avoid the talent shortage? That is his question.
Sorry, could you mention the question again? It's hard to hear.
So there is a question from Mr. Veera Babu. So he's asking what should be done to what's the remedial steps to avoid the talent shortage, to mitigate the talent shortage?
To mitigate the talent shortage, as I mentioned, now we're using the solution that we put more efforts in our education. Education that's for Taiwan, for example, we applicate the manufacturing sessions in high school courses, not just in university, to let the students know the basic information starting from high school. And maybe when they're university, they can get more and more deeper details in not just manufacturing, but also if they have interest, like also in design, in maybe testing, and let them choose the courses they want to. So I would say education is the very important stage for resolving this talent shortage problem. And the other solution that really implements in our company is to have the intern program. We're not just using the intern locally, but also globally. By combining global, like different talents, knowledge in semiconductor industry, I believe that talent shortage can be minimized, but it's not in the near future. I believe it must have a longer and longer practice for this. But I would say education, intern, also investing in the act. But this is for the government side. So yeah, this three is really important.
Yeah.
Okay.
So as one of the leading companies, right? Do you have any plan, to come to India and especially to help to build the manpower? So collaborate with universities like us. Therefore, you will be able to generate, the talent required for the semiconductor ecosystem.
Thank you for asking. So
yeah, Bill. So I think this is a process. Also, I'm also working in the J-Track technology, and so I just have to mention about we have a lot of experience to co-work with the Taiwan University. So we just mentioned is we're located in the Hsinchu, but in the Taiwan, this island is many we call for the science park in the Hsinchu, Taichung, and in the south of Taiwan. So I think also have the many universities located in Taiwan. So currently, we also co-work with the Asia University. Okay, so so last year we co-work with the Asia University. I think this good example is for us. This means we are the company. Name, so just I mentioned with we have some resources the issue right now, but we can figure out, we can recruit in manpower in the field. But actually, if we co-work with the university, we call for this the platform. Means we co-work with, like I mentioned, is in the Taichung area, is the Asia University, and then we can let the student in the university before their graduate, we can let the students that knows the field, the knowledge, and then after they are graduate, and we can use them. So it means we co-work. I think this is a good example, maybe for can reference the way for the Indian. So it means that India we can co-work with the Taiwan, Asia University, even the Taiwan high school or something like, and then we can deliver with all the field needs and co-work with this platform. And then I think it's a good future for the development in the education.
Yeah.
We're still in a discussion. If in the future, if there's any opportunity that we can discuss, we're very welcome and really looking forward for it.
Great. Thank you. Thank you so much, Ms. Hazel, because we have been working with Lungwa, University of Science Technology, where today Professor Paul Chang has joined this meeting. And we have been working with the Asia University already. And also we are working with Yuanzi University. So we would be extremely happy to discuss with the JTRON Technologies, and we will really explore opportunities to have a strong collaboration with Sastra and JTRON Technology. And therefore, that will definitely helpful for building talents, both for India as well as the Taiwan.
Yeah, also the welcome when you come Taiwan is the welcome to visit us in Hsinchu. Welcome and
welcome you.
Thank you. Thank you very much.